Hello and welcome to the 6.3 notes video. We are going to continue working on finding zeros of our quadratics by the next lesson, 6.4. That is when we are going to put together what we're doing today and what we did back in 6.1, finding the axis, symmetry, and vertex. We are going to be able to graph our quadratics. So I'm going to draw a little coordinate plane over here on the corner so we can go over what we've learned already and what we're going to be able to do. So let me draw a little quadratic on here. You guys already learned how to find the axis of symmetry that cuts your quadratic in half and your vertex. Today, well, actually in 6.2, you learned one way to find zeros. You're going to learn another way to find zeros, which is the way that you're going to be able to use more often, which will give us these two little points here. And then in 6.4, we will add in finding this point here. And then with that, you'll be able to graph the quadratic. You'll be able to connect all those into a U and have a quadratic. So today we are finding zeros by factoring. We are going to factor in the exact same way that we did back in 5.6. So if you do not remember this, or if you never did this in the first place, I would look back at 5.6 and make sure that I'm familiar with that. What we did when we were factoring in 5.6 was we found two numbers that multiplied together to equal our last number, and they had to add together to equal our middle number. Once we did that, we wrote them in two sets of parentheses, x plus or minus each of those numbers. And then what's new for today is we are going to set each of those factors equal to 0, and we're going to solve for both of our x-intercepts. Once we get the first one factored, I will explain why we're setting them equal to 0. It's just easier to show you when I have a problem to show you with. So let's start in this first one here. We have f of x equals x squared plus 7x plus 10. We are trying to find two numbers that multiply together to be 10 and need to add together to be 7. So multiply to be the last, add to be the middle. Our numbers that multiply to 10 are 1 and 10 and 2 and 5. So pretty clearly we can see the ones of those that add together to be 7 are 2 and 5. So we are going to write our quadratic in its factored form, which is going to be x plus 2 times x plus 5. Because we are wanting to find the zeros of a quadratic, we want to know when one of those will equal 0. These are currently being multiplied together, these two factors. With multiplication, 0 times anything equals 0. So if this equals 0, the entire equation would equal 0. If this equals 0, the entire equation would equal 0. So what we're going to do is we're going to take each of those factors, we're going to set them equal to 0. So we're going to set x plus 2 equal to 0 and solve. And then we are also going to set x plus 5 equal to 0 and solve. So these are just going to be super simple equations to solve. We will, on this first one, we'll subtract 2 from both sides. We'll get that x equals -2. On the second one, we will subtract 5 from both sides, and we will get x equals 0 minus 5 is -5. So that means our zeros for this first problem are -2 and -5. If I were to plug in either of those numbers for x, my entire equation would equal out to 0. So if I were to plug in -2, -2 squared would be 4, plus 7 times -2, so that would be 4 minus 14 is -10, plus 10 would equal 0. If I were to plug in -5, -5 squared would be 25, plus 7 times -5, that would be minus 35. So 25 minus 35 is -10, plus 10 equals 0. So that was a lot of words there at the end, explaining to you guys that if you plug in either of these numbers, your entire equation will equal 0. Let's keep factoring let's keep setting them equal to 0 and solving. Next one I've got x squared minus 6x minus 16. I need to find two numbers that multiply together to be negative 16, and they need to add together to be negative 6. So numbers that multiply to 16, and then we'll worry about negatives in a second, are 1 and 16, 2 and 8, and 4 and 4. Because I need to multiply to be a negative, I need one number to be negative. Because I want to add to be a negative, I want my bigger ones to be negative. So I'm going to make these guys over here on the right side negative. And now the ones that add together to be negative 6 are 2 and negative 8. So my factored form is going to be x plus 2 times x minus 8. From there, I need to set each of those equal to 0. So I'm going to set x plus 2 equal to 0 and solve. I'm going to set x minus 8 equal to 0 and solve. To solve x plus 2 equals 0, I'm going to subtract 2 from both sides. I get x equals negative 2. So that's one of my zeros. To solve x minus 8 equals 0, I need to add 8. I need to add 8 to both sides. 0 plus 8 is 8. So I get that x equals positive 8. That's one of my zeros. Okay. Let's look at two more problems, and then I'm going to show you guys how much and what work you need to show. I'm showing a lot of work on the notes here. You can show as much as you want, but there's a certain few things that I do need you to show. So I'll show you at the end. We got two more problems for now. Next one is x squared minus 12x plus 20. We are looking for numbers that multiply to 20 and add together to negative 12. Numbers that multiply to 20 are 1 and 20, 2 and 10, 3 doesn't work, and then 4 and 5. In order to multiply to be a positive, but add to be a negative, we are going to need to use two numbers that are both negative. So I'm going to make everybody negative. And the ones that add to negative 12 are negative 2 and negative 10. So I have a factored form of x minus 2 times x minus 10. And I'm going to set each of those equal to 0. So x minus 2 equals 0, and x minus 10 equals 0. Solving out both of those, I'm going to add 2 to both sides. For this first equation, I will get x equals 0 plus 2 is just positive 2. And for x minus 10 equals 0, we'll add 10 to both sides. We'll get x equals 0 plus 10. It's just positive 10. Okay, very last problem. We've got f of x equals x squared plus 5x minus 14. We are looking for numbers that multiply to negative 14 and add together to be 5. Numbers that multiply to be 14 are 1 and 14, and 2 and 7. 3, 4, 5, 6 don't work. 7's already on the list. Okay. In order to multiply to be a negative, we need one number to be negative. In order to add together to be positive, we want our bigger ones to stay positive. So we'll make these little guys negative. And then the numbers that add together to be 5 are negative 2 and positive 7. So our factored form is x minus 2 and x plus 7. Setting each of those equal to 0. X minus 2 equals 0 and x plus 7 equals 0. To solve for x on this first equation, we'll add 2 to both sides. We'll get x equals 0 plus 2 is positive 2. And then to solve for x on the second equation, we will subtract 7 from both sides. We'll get x equals 0 minus 7 equals negative 7. Okay, let's chat about at least how much work you need to show on these. So you need to show your factored form. Because we are solving these by factoring, those are the instructions, you have to show your factored out form. So that is this right here. You do not need to write down what you're trying to add to and what you're trying to multiply to. For those of us, especially those of us who feel like we're good at factoring by now, we probably don't need to write that down. But you are more than welcome to, or if you're struggling to remember what your goal is, I would write those things down. Then you need to write down that you are setting each of these equations equal to 0. We want to see you set up those equations. From there, though, we know that you can solve a one-step equation in your head, most of us. So after you get those equations set up, all you need is your final answer. So everything that I just highlighted or I'm circling in yellow is the bare minimum of the work that you need to show. I'm going to take advantage of the fact that I've got another copy of the note sheet right to the right side of me. So an acceptable way to turn in your assignment with a problem on it would be your factored form, like this. Have each of these set up equal to 0. And then I can solve those in my head. X plus 2 equals 0 when x equals negative 2. X plus 5 equals 0 when x equals negative 5. So what I just wrote down in green over on the second copy, that is how much work you would need to show on your note or on your assignment to get full credit. So when we say show all your work, that is the bare minimum amount of work we would need to see. That is all for 6.3. Thank you very much. Make sure you guys get these glued into your notebook.